Today we're going to be talking about slope fields. So a slope field is also called a direction field, and what this is, it's a way to graphically represent solutions of differential equations. So sometimes when you can't actually differentiate them, you can use a slope field instead. So how to make a slope field? So if we're given this differential equation, what you can essentially do, remember, a derivative is telling you the gradient at a specific point. So at each point, you find that gradient and you draw a small little line with that gradient. So our first one at 1, 1, you plug 1 into both x and y, and we get the gradient of -1. So that line right there that's highlighted, that has a gradient of -1. We can do it again at the point of 1, 2. Plug 1 in for x, 2 in for y, and we get the gradient of -1/2. So then that green line would be a gradient. So here's the thing. Slope fields can be very time consuming. IB is not going to make you do every single line, but they will want you to know how you can find one. So then talking about it, what type of function do you think is made up from it? If you look on the left side, your gradients are increasing, and then further on the right, they're decreasing, and they kind of do a hoop. So we can assume this is going to be a parabola. So then finding possible maximum points on the function of the slope field. Remember, extrema have a tangent with a gradient of 0, which means it is going to be horizontal. So where you see those flat lines, in this case at the point 1, 3, that would be our extrema. So a way to figure out where it could possibly lie, we set our equation equal to 0 and solve. So it's going to be on the line y equals 3x. And if you notice, that extrema is on the line y equals 3x. So an isocline, all the solutions of a differential equation intersecting the curve that have the same slope. So anything else on that line would be in that group. So then Euler's method, this equation is in the formula folder. So again, need to know how to use it. Don't need to essentially memorize this whole thing, but there are things you have to memorize because you have to use your calculator. So H is the step size, they will give that to you. And f of x of n y equals yn minus y to the n minus 1 over h. So here our step size is 0.5. Our differential equation is xy. On the point of 2, 2, we then want to estimate the value of 2. So h is 0.1, f of xy is xy, and then yn equals yn minus 1 plus 0.1 x to the n minus 1 times y to the n minus 1. So here both terms have a y to the n minus 1, so we can factor that out. So yn equals y to the n minus 1 times 1 plus 0.1 x to the n minus 1. So we want to put this in the calculator and evaluate. So how we're going to do this is going to be a lot of extra steps because we are in different function settings. So the first thing is the yn is going to essentially be your technically y1, and then your second group is going to be y2, and we're doing an intersection. But again, we are in different settings. So our calc set. The first thing we need to do is change our settings to sequence. So you press mode, go down 3 times, and go all the way over to sequence and press enter. So now we can do the whole intersection y equals, but it's going to look a lot different. And instead of x and y, it says u and v. So any x is actually going to be u in this case, and v is going to be y. So then filling out that information that we're starting to list, your x min is 0, u of n, which is the same as x, is x or u n minus 1. It's not going to be a subscript like we write. It's just going to be parentheses n minus 1 plus 0.1. This is just your x's. So to get u, you do second and then 7, and that gets you your u symbol. So u of n min is 1 because that is our given point. And then v of n is v n minus 1 times 1 plus 0.1 u, because again, x, and minus 1. And then to get v, it's just second and 8. And then your v in of min is 1, again, because it is your given point. And then you want to press second graph, and you want to go down to where u in is 2, because it wants to find when x is 2, and in this case, u and x are the same. And you go down, and we get un of 2 or y of 2 is 3.86, and that is our final answer. Now, the n that you're using when you're filling all of this out is coming from that x, t, theta, n button.